Hello and welcome back to Math 055. This is a video over section 7.6 and we're going to be solving radical equations. So the first thing I want to talk about over here when we talk about solving equations are opposite operations. So let's talk about opposites, okay, or inverse operations. All right, so if I think about the opposite of addition, I think of subtraction. Okay, so if I want to undo addition, I subtract. Okay, same thing with multiplication. All right, the opposite of multiplication is division. And then if I wanted to take something squared, the opposite of that is by taking the square root of that. Okay, so these are opposites. Okay, and we're going to use this concept here to help us solve radical equations. Okay, so before we do this example here, I want to do another example. Let's just say, that I take the square root of, say, some number x, and I get 5 out of that. All right, so the question is this. All right, if I take the square root of a number and it gives me 5, what's that number going to be? Okay, and that number is just going to be 25. But let's see, how do we get that? Okay, now if I wanted to undo taking the square root of a number, I simply just have to square both sides. Okay, take the square. And I'm going to do that to both sides. All right, remember, we know our answer is going to be x equals 25. Square root of 25 gives me 5. So what I'm going to do here is this. All right, if I take the square root of x squared, no, square root of x and square it, that's just going to give me x. Okay, and if you want to talk about that, why that works, we did this in the last lesson. And we've kind of been doing it all this whole time. But if I take, the square root of x times the square root of x, that's going to give me the square root of x squared, which we know to just be x. Okay, so we can skip all that, and we just know that if I take something, square root of x squared, I'm just going to get x. And then that's going to equal 25. Okay, now on these problems, we do want to check our answers, okay, because we may not get what we want. Okay, so let's check, all right, by plugging the value into our original equation. So if I take the square root of 25, do I get 5? Okay, and yeah, I get 5 is equal to 5, so we're good. Okay, but let's take a look up here, all right, where the square root of x is equal to negative 4. Now what I want to do is solve this. So I'm going to do the same thing. I'm going to square it, okay, and square it. And so what I end up getting here is I get x on this side, and that's going to equal to positive 16, okay? Negative 4 times negative 4 is positive 16, but let's check. Okay, now if I check this back in the original solution, does square root of 16, does that give me negative 4? And so it actually doesn't. Okay, so we actually get that 4 is equal to negative 4, and this, my friends, is false. Therefore, x equals 16, we call this an extraneous solution. Okay, and that's what we've got. So we do want to make sure that we check our answers. But that's the idea. All right, so let's jump into part A over here and solve this. And what I want to do first is isolate my radical. Okay, I can't square it until this part is isolated. So my first step on this one is subtract both sides by 3. Okay, and so I'm going to get the square root of 1 minus x is equal to positive 2. Okay, now to undo this square root, all right, what I want to do is I'm going to square both sides. Okay, and do it to both sides. So when I undo the square root, all I'm left with is just 1 minus x, and then that's going to be equal to 4. Okay, and you can solve this a couple different ways, but let's just go ahead and subtract 1 from both sides and solve for x. And so I get negative x is equal to 3. Now, if I divide by negative 1 and divide by negative 1, then I get that x is equal to negative 3. Now, we must check this in our original equation, okay? So if we check it, I'm going to do 3 plus the square root of 1 minus negative 3. Is that going to give us 5, okay? So I get 3 plus square root, 1 minus negative 3 is really 1 plus 3, and that's going to give me 5. So I get 3 plus the square root of 4, which is 5. And so I get 3 plus 2 is 5, and so I get 5 equals 5. All right, and that's true. All right, so this does work. Okay, that's not extraneous. So that's a solution. All right, let's take a look at the next one. Okay, now what I notice over here is that I have a variable under my radical and I have a variable over here. All right, so this one's going to require quite a few steps. But the good thing is that I have isolated my radical. Okay, that's the only thing on this left side of the equation, and that's what I'm looking for. Okay, now what I'm going to do here is I'm going to square both sides. Okay, now when I square the left side, it undoes the square root, so I'm just left with x plus 18. Now, if I square, whoops, didn't square that side. Okay, if I square the right side, I'm squaring a binomial, which means I'm really doing x minus 2 times x minus 2, and I have to multiply that out. Okay, and so we can FOIL it, or you can use box method. So I've got x squared minus 2x, and then plus 4. And that's all equal to x plus 18. Okay, so now so now look what you got. Okay, I got x plus 18 is equal to a quadratic, all right, into a polynomial, or a trinomial. X squared minus 4x and then plus 4. Now remember what we're trying to do here. We're trying to solve for x. So if I have a quadratic, then what I have to do is I have to move all these terms, x plus 18, to the other side and set my trinomial equal to 0, okay, and then factor it. All right, so here's what I got. I'm going to subtract x from both sides. I'm going to subtract 18 from both sides. So here's what we get as a result. We get 0 is equal to x squared minus 5x and then minus 14. Okay, and this I need to solve for x. Okay, and what I'm going to do is when I factor this, I'm going to use the box method. Okay, and so I've got x squared negative 14, so I've got x and x, so you know all those things we learned in chapter 5 we got to come back to, okay? And then two numbers that are going to multiply to negative 14 but add to negative 5. So I'm going to do negative 7 and positive 2. So this is going to give me 2x and this is going to give me negative 7x. When I combine my like terms here, I get negative 5x, and that's what we're looking for, so we're good. Okay, so what this does is this is going to factor now. Let's rewrite our equation. 0 is equal to x minus 7 times x plus 2. Now, since I factored this, what I want to do is set each of these binomials equal to 0 and solve for x. So I've got x minus 7 is equal to 0, and then I've got x plus 2 is equal to 0. Okay, so I'm going to add 7 to both sides, and I'm going to get that x is equal to 7. I'm going to subtract 2 from both sides, so I get x is equal to negative 2. All right, so these are my solutions, all right, but I need to check them to see if they're extraneous. Okay, so my question is this, all right, if I take, all right, so let's do this. Let's plug it, check 7. Okay, so x equals 7. So if I do the square root of, let me do this, square root of 7 plus 18, is that equal to 7 minus 2? All right, so I get square root of 25 is equal to 5, and I get 5 equals 5. So this one is good, okay? That one's good. All right, let's check negative 2. All right, so if I plug in negative 2, I'm going to get the square root of negative 2 plus 18. Is that going to equal negative 2 minus 2? All right, so equal to negative 2 minus 2. So this is going to give me the square root of 16. Is that equal to negative 4? Square root of 16 is 4, and that does not equal 4. So this is false, okay? Okay, so when we check these, all right, we get that one of the solutions that we got algebraically worked and the other one didn't. So here's what I've got. Here are my solutions. All right. So I've got x is equal to 7 and x equals negative 2 is extraneous. Okay, we need to label that. Is extraneous. Okay, and that's what that means. Okay, it means that we get it algebraically, but it doesn't work for the problem. Okay. And that's that. Okay, let's take a look at the last one, part C. And what I want to do, because notice what I have here. I have two radicals. So I can't isolate my radicals, but I can't isolate a single radical, but what I want to do is get the radicals on both sides. Okay, so what I'm going to do is this. I'm going to add the square root of x to both sides. All right, and what we're going to get on the left side is 1 plus the square root of x, and that's going to be equal to the square root of x plus 9. Okay, that's the first step, is that we want to get the radicals on the opposite side. Now here's what's going to happen. Okay, I'm still, because I have this radical isolated, I still want to square both sides. Okay, I'm going to square it here and square it here. All right, so as a result, okay, on the right side, I'm going to get x plus 9. Okay, that just gets rid of my square root. Now on the other side, I'm going to get 1 plus the square root of x, and I'm going to get 1 plus the square root of x. Okay, now watch what I do here. Watch what happens. All right, if we multiply this out, 1 times 1 is 1, plus square root of x times 1, so plus the square root of x. Square root of x times 1 is plus square root of x. And then square root of x times the square root of x gives me plus square root of x squared. Okay, and that's going to be equal to x plus 9. Okay, so now look what we got. Over here, I've got 1 plus. These are like terms, so I'm going to get 2 square root of x, and then just plus an x is equal to x plus 9. Now watch what happens here. I'm going to subtract, I'm going to move everything else over. I'm going to isolate my square root of x here. So I'm going to subtract an x from both sides, okay? And I'm going to subtract 1 from both sides, all right? So let's put this up here, okay? And so then we're going to get this. We're going to get 2 square root of x is equal to, now this cancels out and this cancels out, which is pretty cool. 1 minus 1 cancels out, so we're just left with 9 minus 1, which is 8. Okay, now look what we get. Okay, now I have a new equation with just a single radical, okay? And so as a result, I'm going to divide both sides by 2 and by 2, and I'm going to get that the square root of x is equal to 4. Now what I want to do is I'm going to square both sides, okay, because that's what I do, and we're going to get that x is equal to positive 16. Okay, now what I want to do is check this to make sure that this works. All right, so this is my one solution that we got. Okay, sometimes you get more than one solution, but that's what we got. And we're going to plug this in. So I got 1 is equal to the square root of 16 plus 9 minus the square root of 16. Okay, and so as a result, I get 1 is equal to, okay, 16 plus 9 is going to give me 25, so square root of 25, minus the square root of 16. So I've got 1 is equal to 5 minus 4. Now 5 minus 4, that's just going to give me 1, and 1 is equal to 1, and this is true, so this solution works. Okay, so that's the idea. On this last problem, you guys will probably encounter one where it doesn't like necessarily work out as nice and neat as that, but you know, let's go ahead and get started on the homework, and we'll talk to you soon. Thanks a lot. Bye.